Hello, this video is for Graphing Calculator Lab 1-6A, and I'm going to answer questions 2 and 4. The directions tell us to solve each inequality, then sketch the graph and draw the number line that represents the solution set, and to give the solution set. We see in number 2, we have an absolute value of x plus 2 is greater than or equal to 6. And they give us a hint that tells us to set the graph equal to y1 equals the absolute value of x plus 2 minus 6. Where do they get that? Well, they really just set this equal to 0 by subtracting 6 from both sides. So this is now 0. And what we're going to graph is x plus 2, absolute value of x plus 2 minus 6 is greater than or equal to 0. But what we're just going to put into our graphing utility is this function. Now, if you turn on your calculator, graphing calculator, and go to y equals, I've put this in already, but if you want to clear out anything else that you have, I'm going to clear that out. You press clear to get rid of anything in here. So where's the absolute value? If you remember, it's in the math and num. You have to scroll to the right to get the absolute value function. Okay, so you can choose number 1, which puts it into your y equals if you have started from y equals. Okay, and then we press x plus 2, and then we end the absolute value symbols, which in this case are parentheses, and then put in minus 6. Okay, so we've put our function in. Now remember, we're looking for where this is greater than 0 because we did solve this for being greater than 0. Let's look at our graph. So the graph is being drawn on a 10 by 10 window. If you don't have a 10 by 10 window, go to zoom number 6, which will give you a standard window. 10 by 10. Remember that when we have a parent function of absolute value, we get a v, something like that, but because we've got a transformation of x plus 2, it moves it to the left 2, and a minus 6 moves it down 6, you'll notice that your vertex here is at the point -2, -6, and if you're not sure about that, let's look at the table. The table tells us that at -2, we are at -6. I'm sorry, yeah. -2, -6, right there. Okay, so we have that point, -2, -6, 1, 2, 3, 4, 5, 6, and -2, -2, -6 is right about there. Okay, now we also want to know, where does this cross the x-axis? Where are the zeros? Sorry, just trying to get a better view here. Where are the zeros? The zeros are where the function crosses the x-axis. So I can see on my graph that it crosses the x-axis here and here, and on this particular function, if I just look at a table, I can see that there are zeros at -8, when x is -8, y is 0, and so that's going to be over here, and at, the other one's a positive number, it's +4. It goes from being negative to positive and crosses at x is 4. When x is 4, y is 0. So over here I'm going to put 1, 2, 3, 4, 5, 6, 7, 8. At -8, I have a 0. And at 1, 2, 3, 4, +4, I have a 0. And basically it makes our v here. And so I'm going to use a straight edge here. And I'm going to start with my pencil on one of my points to draw that. Hold it straight up and down. And to draw that, put it right here on 4, move my ruler in, and draw. Okay, so this is this function here. The absolute value of x plus 2 minus 6 is greater than or equal to 0, but this is the function right here. Now, what about these questions? What is the solution set to when is this greater than 0? Greater than or equal to 0? Well, it's greater than or equal to 0 when it's above the x-axis. That's when it's positive or greater than 0. Here being 0 and here being greater than 0. So I need to give all the x's where it's greater than 0 over here, which is all x's that are greater than or equal to -8. These. And all x's that are, or all x's that are greater than or equal to, I'm sorry, this is less than or equal to -8, excuse me. All x's that are less than or equal to -8, or all x's that are greater than or equal to a +4. and we'll put that in set notation. So it's a solution set. And then on this number line here, we're going to put 0, we're going to put -8, and we're going to put 4, and we're going to say from this spot to the left and from this spot to the right is the solution set, is the graphed solution set. Okay, so we have graphed the function, we have given the solution set as set notation, and we have